Welcome back to the Deep Dive, folks. Today we're taking a look at a paper that's been making waves. It's called YuE, Scaling Open Foundation Models for Long-Form Music Generation. And with me to break it all down is, well, an expert.
That's me. Happy to be here. And you're right, this paper's a big deal. We're talking about AI generating full songs with vocals, all from just lyrics.
It's one of those things, right, where the idea itself has been around for a while, but actually seeing it done well is, well, impressive. I mean, the possibilities here are huge, from new ways to create music to personalized experiences, maybe even therapeutic uses.
No doubt. And we've seen glimpses of what's possible with systems like Suno and UDO, but those are proprietary closed systems. So the research community's been somewhat in the dark.
Kind of like watching a magic trick but not knowing how it's done. And that's where YuE comes in, right? It's open source, so we can finally see under the hood and understand the process. Plus, they're claiming it rivals those closed systems in quality, which is a big claim. So where do we even begin with something this complex?
Well, at its heart, YuE is a family of models based on the Llama 2 architecture, but scaled up massively. We're talking trillions of tokens. That scale is what allows it to capture those intricate relationships between music and language. They've designed it to create songs up to 5 minutes long, which is significantly longer than most previous systems.
5 minutes is a proper song, not just a snippet. But the real challenge is making it all work together, right? Lyrics, melody, structure, accompaniment, it needs to be cohesive.
Absolutely. And that's where their technical innovations come in. One of the key ones is what they call track decoupled next token prediction, or dual NTP for short.
Dual NTP, got it. So what's that all about?
It's a clever way to address a fundamental problem. Think about a song. You've got vocals and instruments happening simultaneously. Now, standard next token prediction, the way a lot of language models work, can struggle with that. It's like trying to understand two conversations happening at once. The dominant part, often the instruments, can overshadow the vocals.
Like trying to listen to a friend in a noisy bar. Makes sense.
Right. And they actually quantify this problem with something they call linguistic information loss after tokenization, or LLAT.
LAT, another acronym to keep track of. So what is LAT telling us?
It measures how much of the information from the lyrics is actually lost when you convert the raw audio into those discrete tokens that the model works with. They found that genres with dense instrumentation, like metal, have a higher LAT.
Because the vocals are basically buried in the mix.
Exactly. So their solution with dual NTP is to essentially split each time step into two tokens, one for the vocal track and one for the accompaniment.
So instead of one token representing the whole mix, you have two, keeping them separate. Clever.
It's elegant because it keeps the basic language model architecture intact, but allows them to model the vocal and instrumental parts more effectively.
Less muddled, more clarity.
Precisely. And that leads to better lyric adherence, especially in those challenging genres where the vocals might otherwise get lost.
Okay, so dual NTP solves the too much happening at once problem. What's the next hurdle they tackled?
Maintaining coherence over a longer piece, an entire song. For that, they introduced structural progressive conditioning, which they call COTE.
COTE. Okay, so we're talking about keeping the song on track, making sure it makes sense from start to finish.
Exactly. With standard methods, the initial input, the lyrics, can have a diminishing influence as the generation goes on. Like a game of telephone, the message gets distorted the further it travels.
So how do they make sure the AI doesn't lose the plot?
By taking advantage of music's natural structure. Think intro, verse, chorus, bridge, outro. These are the building blocks of a song.
Makes sense. A song isn't just a random jumble of sounds. It has a form.
Right. So they automatically segment a massive data set of songs into these sections. Then, during training, they feed the model these segments in a structured way, interleaving the lyrics, special tags for each section, and the corresponding audio tokens.
So it's learning not just the notes and words, but also the blueprint of a song, how it flows.
Precisely. This guides the generation process so that the AI is always aware of where it is in the song and what should come next.
Now, the third technique they highlight is music in context learning, or ICL. We've seen ICL in language models, but how does it work with music?
They had to adapt it quite a bit. See, traditional ICL for speech often needs reference text along with the reference audio. With YuE, they've made it more flexible.
So you can give it more specific instructions on the style you want?
Exactly. In their single-track ICL mode, you can provide just the instrumental, just the vocals, or the full mix as reference. And in dual-track mode, they even interleave the vocal and instrumental tokens from the reference audio.
I'm guessing this is what allows for things like style transfer.
You got it. They have an example where they take a Japanese city pop song with a female vocalist and generate an English rap version with a male vocalist, all while keeping the original instrumental style.
Wow, that's impressive. But they also mention a delayed activation strategy for ICL. Why not use it from the start?
Because ICL is such a strong signal, if you activate it too early, the model might overfit to the reference audio, basically just copying the style, instead of learning to generate something new and original.
So they let it develop its own musical understanding first, and then fine-tune the style later on.
It's like learning the basics of a language before trying to mimic a particular accent. And speaking of stages, YuE actually has a two-stage generation process.
Okay, so what's the breakdown between stage 1 and stage 2?
Stage 1, which they call music language modeling, focuses on generating the core musical content. It takes the lyrics, the structural information, and any other conditioning you provide, and predicts a sequence of what they call code book 0 tokens. Think of these as a high-level representation of the melody and the overall musical idea.
So stage 1 is like sketching the musical concept.
A good analogy. Then comes stage 2, residual modeling. This stage takes those initial code book 0 tokens and refines them, adding the detail and texture.
So the finer points, making it sound like a real song.
Exactly. And to do all this, they need a way to represent both text and audio within the model. For text, they use the standard LLAT tokenizer, breaking down words into smaller units. For audio, they use something called codec.
Codec, yet another thing to remember. What's so special about it?
It's a semantic acoustic fused codec, meaning it captures both the meaning and the sound of the audio. They actually use the first 8 layers of a much larger codec, which is interesting.
So the AI isn't just hearing sounds, it's understanding them on a semantic level as well.
In a way, yes. It's like understanding both the notes on a page and the emotion they convey when played. They also expanded the model's vocabulary to include special tokens that indicate things like the start and end of audio segments, the stage of generation, even the type of audio tokenizer being used.
Yeah.
Oh, and they also use a technique called upsampling, which increases the audio resolution to 44.1 kilohertz for the final output.
So a lot of clever tricks to get that high fidelity sound, but this model is huge, trillions of tokens, you said. How did they train something this complex?
It wasn't easy. They had to get creative with their data, especially since there's not a ton of high-quality data that perfectly pairs lyrics with complete songs. They used a multitask, multi-phase approach.
Multitask, multi-phase. So break that down for us.
Multitask means they trained it on different types of data. Lyrics to song data, obviously, but also text-to-speech data, music without lyrics, even tasks that involve separating vocals from instruments in mixed audio.
Giving it a broad musical education.
Exactly. This helps the model learn different aspects of music and speech independently and then figure out how to combine them for song generation.
And the multi-phase part.
That refers to the different stages of training, each with a specific focus. They start with a warm-up phase, use a smaller, high-quality data set. Then they move to a constant learning rate phase with the larger, more diverse data set.
I imagine that helps it generalize better.
Exactly. Then a phase focused on handling those longer sequences, and finally a fine-tuning phase where they gradually reduce the learning rate and introduce things like reference audio and genre tags to give it more control.
Sounds like a carefully crafted training regimen. But the real question is, how well does it actually work? They compared it to some big names in the field, right?
Yes, both through human evaluations and automatic metrics. In the human evaluations, they found YuE to be comparable to systems like Tian Gong and Nudio, even outperforming YuE. But it still lagged behind Suno v4 in terms of overall quality.
So in the same league as the top players, but still room for improvement.
And the feedback was interesting. YuE scored particularly high for music structure and arrangement, which highlights its strength in creating those long-form pieces.
So it gets the big picture right.
But there were some weaker points in the acoustic quality of the vocals and accompaniment. They speculate this might be due to limitations in the audio tokenizer.
So musically strong, but needs a bit more polish on the sound itself. What about the automatic metrics? Did those line up?
Not entirely, which isn't uncommon when you're dealing with something as subjective as music. YuE did very well on metrics that measure how closely its output matches the statistical properties of real music, things like KL divergence. And on some metrics that try to quantify aesthetic quality, it was also competitive. But metrics that focus on the alignment between lyrics and music were a bit more inconsistent.
So some metrics liked it, some were less impressed. That sounds like a challenge for evaluating generative AI in general, though.
It's an ongoing problem. YuE did score high on Clambay 3, which seemed to correlate well with how humans judged its controllability, meaning how well it follows instructions. But on CLAPA score, it was lower, and that didn't match up with human preference as well.
So picking the right metrics is crucial. Anything else stand out from the evaluations?
One interesting finding was the strong correlation between the range of the generated vocals and how much listeners enjoyed the musicality. The wider the vocal range, the higher the perceived musicality.
So a good singer makes for a good song, even if the singer is an AI.
It seems so. And they found CLAMPE 3 was a better predictor of how well humans felt it was following instructions than CLIP score was.
Good to know. Now, this wasn't just about English music, was it? They also looked at other languages.
They did. They fine-tuned YuE on Chinese, Korean, and Japanese lyrics, and the results were promising, particularly in terms of how well the generated music followed the lyrics.
So it can handle the nuances of different languages. Impressive.
The best lyric following was in Japanese, and the musicality was competitive in both Chinese and Korean.
Okay, so now for the flip side. The paper also talks about their unsuccessful attempts. Why highlight the things that didn't work?
It's incredibly valuable information, both for other researchers and for understanding the limitations of current methods. It's about transparency and helping the field progress. For example, they discuss how using purely acoustic tokens for audio led to training difficulties and lower quality output compared to their semantic acoustic tokens.
So learning from mistakes.
Exactly. They also found that just scaling up pre-training without a specific goal in mind became counterproductive at a certain point. They called it catastrophic inertia.
Like trying to push a boulder uphill, it gets harder the bigger it gets.
A good analogy. And they also learned that introducing in-context learning too early can lead to overfitting and a decrease in the model's ability to be creative.
So timing is everything. So to sum it all up, what's the big takeaway from you? Why should people care about this research?
Well, it's a huge step forward for open source AI music generation. It's the first publicly available model that truly rivals those big closed systems in its ability to generate full songs from lyrics. And because it's open, it opens up a world of possibilities for research and development.
Democratizing access to this kind of technology is a big deal. What kind of impact could this have in the real world?
The potential is vast. We could see more personalized music experiences, new tools for music creation that are accessible to everyone, and even entirely new art forms that blend human creativity with AI capabilities. Plus, the open nature of YuE fosters collaboration and responsible development.
A rising tide lifts all boats. Now, for our Novel Notions segment, where we speculate on future directions based on this research, what are some ideas that come to mind?
One that I find particularly interesting is the idea of dynamic genre fusion using reinforcement learning.
Dynamic genre fusion, that sounds cool. Tell us more.
So YuE already does style transfer based on reference audio. But imagine taking that a step further and letting the AI blend genres in real time based on feedback from the listener. Maybe using biofeedback or direct input to gauge their preferences.
So the music adapts to how you're feeling or what you want to hear.
Exactly. The music could shift and evolve, creating a truly unique and interactive experience. And YuE shows that it can spontaneously mix patterns from different genres, so reinforcement learning could provide a way to control and refine that.
It's like a personalized DJ that's constantly remixing the music based on your mood.
In a way, yes. And it raises all sorts of interesting questions about how we define genres and musical identity if they're constantly in flux.
And what about from a technical standpoint? Is this even feasible?
Given the current state of style transfer and reinforcement learning, I'd say it's definitely within reach. But the bigger question is whether people will actually enjoy this kind of dynamic, ever-changing musical landscape.
It's a fascinating concept. What's your second novel notion?
This one builds on YuE's understanding of musical structure. What if we could go beyond generating music from lyrics and create a truly bi-directional model where the generated musical structure influences and shapes the lyrics as well?
So the music could be inspiring the lyrics instead of just following them.
Exactly. YuE understands how songs are structured, how they flow. A bi-directional model could leverage that to create a more integrated songwriting process where the music and lyrics are in constant dialogue.
It could even help lyricists, right? Giving them musical cues to spark their creativity.
Absolutely. But there are challenges, of course.
Yeah.
How do you balance the AI's influence with the human writer's intent? Could it lead to a homogenization of song structures if the AI favors certain patterns?
A lot of open questions, but the potential is exciting. It's a glimpse into a future where AI and humans collaborate more deeply in creative endeavors.
Definitely. YuE gives us a solid foundation to build on.
Well, on that note, we've reached the end of our deep dive. It's been a fascinating exploration of the research behind YuE and its potential to revolutionize the world of AI music generation.
It's been a pleasure.
If you're intrigued by what you've heard, we encourage you to check out the paper and the demo page. The links are in the show notes. And as always, we'd love to hear your thoughts and questions.
Absolutely. Keep the conversation going.
Thank you for joining us on this deep dive into the fascinating world of AI music generation. Until next time, keep exploring.